Okay, the answer for number 1 is choice B. So if you got that and you didn't guess, you can move on. If you look at this question, it does say as x approaches infinity. So what I'm going to do is I'm going to look for n behavior. So I'm going to pick the highest power in the numerator. Now, if we look at this, I'm just going to, you can double distribute, but I'm going to kind of cheat here and just take the highest power in each of those parentheses. And when I do that, that ends up giving me a negative 2x squared. And then I'm going to do the same thing in the denominator. Again, I could double distribute the whole thing out, but I know that the highest power in each of those parentheses will multiply to x squared. And then I know that the x squared is going to cancel out, and there's my answer of negative 2. Number 2's answer is D. So if I look at that, that's technically the integral of dx over x squared, which I would rearrange that and make that x to the negative second dx. And then when we integrate, remember we add 1, so that's x to the negative first over negative 1, plus c. And then really, if we look at that, that's really negative x to the negative first plus c. The answer is choice D. Okay, now this question really isn't that difficult, but what is difficult is making an answer that you get, which is probably correct, look like choice D, or any of the choices. You know, obviously when you started this question out, you didn't know it was choice D. So let's just start off. So I'm going to start by doing the product rule. Oops, okay. So that's the first times the derivative of the second. Okay, now I'll be a little careful here because we're going to have to do chain rule. So we're going to have 3 times x squared plus 2. That raised to the second power, and then we have to take the derivative of the inside, which is 2x. Plus the second, which is x squared plus 3, that quantity cubed. Oh, I'm sorry, x squared plus 2, that quantity cubed. And then times the derivative of the first, which is really just 1. Okay, so this is the part that might be a little bit tricky. So listen, we did it right, but the problem is that answer choice isn't there. I want you to look at this, and we have a sum right here, and this is one part of the sum, and this is the other part of the sum. And what I want you to notice is if you look at both of those things that I underline in red, they both contain an x squared plus 2. So they both contain that factor of x squared plus 2. And the reason why I'm focusing in on that also is if you look at all of these multiple choice, all of them have that x squared plus 2. That kind of seems to be the underlying theme, so to speak. So then I kind of figure, well, you know what, maybe what I want to do is factor out that x squared plus 2. So I can factor out x squared plus 2. I can factor out 2 of those from both sides. And let's see what I have left. Well, on the left-hand side there, I'm going to have an x minus 1. Then I've got that 3. And then I've got that 2x. And I'll simplify that in a minute. Plus, and then on the other side, if I take out an x squared plus 2, 2 of them, I still have one of them left. Okay? All right. So then I've got x squared plus 2, that quantity squared. All right, now let's try to simplify what's inside these parentheses a little bit. So I know that here I'm going to get 6x, right? So let me just write that above there. So I've got 6x here, and then I'm going to distribute that through to the x minus 1. So that's going to give me 6x squared minus 6x, and then I've got plus x squared plus 2. Okay, and then if I keep going, let's keep bringing down my x squared plus 2, that quantity squared. And then in here, I'm going to get 7x squared minus 6x plus 2. And there's your answer, choice D. Answer is choice B. What I would probably do is I would separate these this question rather, into two separate integrals. So I would do the sine of 2x dx plus the integral of cosine of 2x dx. Now, I see that both of these have a 2x, so I'm going to make that my u, and my du is going to be 2dx, which means each of these integrals needs a 2 on the inside and a 1/2 on the outside. So I'm going to have a 1/2 on the outside, right? And now I'm integrating, let's start with the first one. So I'm going to be integrating sine of u. And the integral of sine is negative cosine. So negative cosine u, right, plus c. I'm going to put that at the end. Well, okay, I'll put it here, plus c. Plus, and then I'm going to integrate my cosine of u, and the integral of cosine is sine. But remember again, I have a 1/2 in front, okay? So that's going to be 1/2 sine u, and oops, I can't fit it, but I'm going to stick it up here, plus c. Sorry, that looks awful. All right, so let's make this look a little prettier. So I have negative 1/2 cosine u plus 1/2 sine u. And about those c's, a c and a c is still a c. It's a constant any way you look at it, so we can just write plus c like that. We can combine them. And then lastly, let's just replace our u's with 2x. Okay, and then we've got plus c, and there's your answer, choice B. The answer is choice A. Now you can do this question actually two ways. You can do the L'Hopital's rule, or you could factor. So that's completely up to you. I'll show you both ways. All right, so if you plug in 0 right away, obviously you're going to get 0 over 0, so we have an issue there. So what I did was I took out an x squared, and I would get 5x squared plus 8. And then in the denominator, I would also take out an x squared, and I would get 3x squared minus 16. And I could see that those factors cancel out. Now if I plug in 0, I'm going to get 8 in the numerator, negative 16 in the denominator, and that's negative 1/2. So there's your answer. Now if you want to do L'Hopital's rule, remember that's the derivative of the top and the derivative of the bottom. Okay, so when I start that, I have the limit as x approaches 0. And if I take the derivative of the top, I get 20x cubed plus 16x. And in the denominator, I get 12x cubed minus 32x. Well, the problem is if I plug in 0 here, I'm still going to get an indeterminate. So the L'Hopital's rule says take the derivative again. So, oops, that's supposed to be the limit. Sorry, that looks awful. As x approaches 0. And I'm going to take the derivative again. So I get 60x squared plus 16. And then I get 36x squared minus 32. Now if I plug in 0, you'll see that I will end up getting 0 here and here, but plus 16 and the minus 32 will stay. So when I do that then, I end up with 16 over negative 32, which is negative 1/2. So you take your pick, whichever way you prefer. The answer is choice A. Now, to be honest with you, I see in the first part of the piecewise function that I have x squared minus 4 over x minus 2. And I know that I can kind of simplify that a little because the numerator can factor. Oops. Get that out of there. Here we go. And x minus 2. So that's really just the line x plus 2. I'm a visual person. I would like to draw a picture. That's just me. Okay. So if I just do like a brief sketch, nothing crazy, What I do notice here, and let me just kind of focus in on this, is that this is the line x plus 2, but notice x can't equal 2 here. Okay, so that's going to mean that we have an open circle. And if I plug in the x value of 2 here, I'm going to get 4. So I know that the line has a slope of 1, and it will have an open circle at 2, 4. Okay, so let me go to 2, 4. I'm going to put an open circle here. It has a slope of 1. And so generally speaking, it's going to look like that-ish. Okay? All right, now let's talk about the second part of the piecewise function. Here it's telling you y is equal to 1 when x is equal to 2. So in other words, this is the point 2, 1. Okay, so I'm going to plot that. All right, so 2, 1. So that's what the graph looks like. Now, if you look at that graph, I think you pretty much, this should be touching that circle, should be able to answer the question. So let's look at the Roman numeral 1. It says that the function has a limit as at x equals 2. It does, because the limit coming from the left equals the limit coming from the right. Okay, remember, it doesn't have to actually be a closed-in circle here, so that's true. Now, let's look at Roman numeral 2. F is continuous at x equals 2. Well, it's not, because we've got a hole here. Continuous would mean that I could just take this arrow and not have to lift it up to go over this hole to get to the other side and continue on my journey there. Okay, so 2 is false. All right, f is differentiable at x equals 2. That's Roman numeral 3. Well, listen, if the function is not continuous at x equals 2, it can't be differentiable at x equals 2. Definition of differentiability means, states that you have to have a continuous function. Okay, so that's why your answer is choice A. The answer is choice B. Whoops, maybe I should put my pen on. There we go, choice B. All right, well, they give you the velocity equation, and here they're talking about the position, twice actually. First, they talk about the position x equals 2 at time 0. So what that's really giving you then is that x at time 0 is 2. And then here, they want to know what is the position of the particle at time 1. So x of 1 equals what? Well, we can't answer that question until we actually have a position equation. So we're going to integrate the 3t squared plus 6t dt, and let's get ourselves a position equation. Okay, so that's going to give us x of t equals, and that will give us t cubed plus 3t squared plus c. Okay, well, they gave us that value of 0, 2. Okay, that's where I'm getting that from. All right, so let's plug it in and see what we get. So we get 2 equals, now I'm plugging in 0. So that's 0 plus c. So I see that obviously that c is 2, right? So x of t is equal to, I'm just going to rewrite it, t cubed plus 3t squared plus 2. And then they want x of 1. So I'm just going to plug in 1. So that's 1 cubed plus 3 times 1 squared plus 2. Do that handy dandy little math there, and you are going to get 6. The answer is choice E. So we are going to start by taking the derivative. And I know that the derivative of cosine is negative sine. So I'm going to do this. I haven't forgotten the negative, don't worry. So I know cosine is negative sine, but then I have to take the derivative of the inside, right, which is 3. So I'm going to make that negative 3. Okay, so there's my derivative. Now they want me to plug in pi over 9. Okay, so negative 3 times the sine of 3 times pi over 9. Well, I can then take that pi over 9 with that 3 and you see that that becomes pi over 3. And I know that pi over 3 is, oh boy, 60 degrees, right? So then I just look up, or in my card catalog, in my brain, because I haven't memorized, what did I say that was? The sine of 60, right? Okay, and I know that the sine of 60 is radical 3 over 2. So then that's negative 3 radical 3 over 2. The answer is choice D. Okay, now this is probably something that we haven't spent a lot of time on. It's not a difficult concept, but it's going to take me a little bit to explain it. Okay, so they give you this formula right here, so I'm just going to use that formula. I'm going to do each one though, because we want to see which value ends up being the greatest. So I'm going to just start with G, and I'm going to replace that x with a negative 3 equals, so it's going to be the integral from negative 2 to negative 3 of f of t dt, right? F of t dt. Well, remember, you can't have an integral where your bottom bound is higher than your lower bound. So what I'm going to do is I'm going to negate and flip those bounds. So negative 2 in the top, negative 3 in the bottom, and f of t dt. Okay. So basically what this is asking you to find is the area under the curve from negative 3 to negative 2. Okay, so just to give you an idea, and I won't do the area under the curve for every single one, but negative 2 to negative 3 would just be from here to here, so it's asking for that area. So you're finding the area of that trapezoid. Now remember though, the area of that trapezoid, when all is said and done, we're going to negate because we flipped our bounds. Okay, so, oh boy, remember area of a trapezoid, oops, I thought my pen was on there, is 1/2 the height. Now, this is your height right here. So that height is 1. And then base 1, which is 1, plus base 2, which is 2. Okay? Just so that you see how I'm getting the answer that I'll be getting. All right, so when that is all said and done, that ends up being what? We've got 3, so that's going to be negative 3/2, right? So negative 3/2. All right, so there's the answer for choice A. Let's go to choice B. So choice B is asking us to find g of negative 2. So that would be the integral from negative 2 to negative 2. Well, we can just stop right there, right? We know that that is 0. Okay, C. So then we want g of 1. Oh, I'm sorry, g of 0. I can't read it. So g of 0 is asking you to integrate from negative 2 to 0, f of t dt. Okay, so basically what you want to do is you want to find the area under the curve from negative 2 to 0. And you're going to look from negative 2 to 0, so that would be this space right here in green. So you're going to do area of a trapezoid again, right? All right, so that would be 1/2 the height, and the height this time is 2. And then we're going to do base 1 plus base 2. So that's 1 plus 2. Okay, and when we do that, we end up with an answer of 3. So far that's the front runner. All right, let's go to D. And again, not that any of this is hard. It's annoying, yes, but not hard. All right, we want g of 1. So we want the integral from negative 2 to 1 of f of t dt. Okay, so this one, we're actually doing what we just did in green plus this triangle right here on the right-hand side. So I'm going to also keep that in green. So the area of that triangle is 1/2 the base, which is 1, times the height, which is 2. Okay, and again, so then I would be adding these two together to get my answer for choice D. Okay, so I know that the area of the trapezoid was 3. That was the answer for part C, plus the area of that triangle, which is 1. So final answer is 4. Okay, so far We got that, right? All right, now let's look at choice E. Choice E is asking us to do g of 2, which is the integral from negative 2 to positive 2 of f of t dt. Okay, so let me just talk about this for a second, because let's not even bother doing the work. What you should hopefully see, and let me do this, is this space here and this space here are equivalent, except that that area is positive and this area is negative. So won't these two areas cancel each other out? So when I'm integrating down here from negative 2 to 2, I'm going negative 2 all the way over to positive 2. But really, these guys are going to end up being 0. So the integral from negative 2 to positive 2 is really just this trapezoid. Okay? And that is the answer to choice C, which was 3. So I'm just trying to avoid having to do all of the work for it because I'm lazy. So now you can see that choice D is your answer, 4. The answer is choice C. Okay, so I just drew pictures. I think it's probably the easiest way to go with this. So if you look, this is my left Riemann sum, and you can see that I have an over approximation here. I probably have one here and here. Honestly, I do. I just didn't draw the best picture in the world. Sorry about that. So you can see that this is an over approximation, and they want to know which of the following has the least value. Listen, this is an exact value. So basically, what I mean by that is the area from 1 to 3 would be everything in here, exact value. Okay, I'm such a good drawer, aren't I? So when we are then looking at our answer choices, we're looking for something that's an under approximation, which the left is not. The right is. Now, midpoint, kind of a cruddy picture, but that looks like, see right here, we got some space. This is also an under approximation, but there's way more space here in that right Riemann sum picture than my midpoint. And here's my trapezoidal. I'm sorry I didn't write it. Again, I've got some space here, but nothing really significant. Okay, so that's why I'm going to say, I'm going to just write here, this is my trapezoid, okay, that it would be the right Riemann sum. The answer is choice B. I would do a sign chart for the derivative. I have a picture of the function, so I'm looking for increasing, decreasing. So I see that my function is increasing until I get to a certain point. Now, I'm not sure what that point is, but I do know that it's a negative number, so I'm just going to write negative number there. Then the function starts decreasing. Right? Just look again. So I'm going increasing. Now I'm decreasing till I get to some positive number. Right? So then this will be some kind of a positive number that I'm not sure of. And then after that, I start increasing again. So when I'm looking for the graph of the derivative, remember I want a picture that starts above the x-axis, then goes below the x-axis, and then above, because I'm looking for a picture of the derivative, and this is a derivative sign chart. So derivative picture, derivative sign chart, above, below, above, which is choice B. Now, just want to show you that choice A also has above, below, above, but this is what you have to focus in on. We hit the x-axis here at a negative number. And here I'm not hitting at a negative number, I'm hitting at 0. And that's why the answer is choice B and not choice A. The answer is choice D. Okay, so we're going to take the derivative, right? So remember the derivative of an E is e to the u du, right? So e to the u, and now I have to take the derivative of that 2 over x. Okay, so let's talk about that. Well, let me just throw that right down here. So if I have 2 over x, that's really the same as 2x to the negative first. All right, so I want the derivative of 2x to the negative 1. So then remember, I'm going to take this exponent, drop that in front, so that's going to make that negative 2x to the negative second power. And I'm just going to make that look a little prettier, and that's going to be negative 2 over x squared. Okay, so that is where I'm getting this from. So negative 2 over x squared. And then you can see that this is answer choice D. All right, so the answer is choice A. So they're giving you the function f of x, right? And they're telling you that it's x squared plus 2x. And then what they're asking you to do, I'm going to just ignore this for right now, and I want to look at this. So then what they're asking me to do is replace x with ln of x. So I'm going to replace all my x's with ln of x, just like this. Okay, I'm just substituting in a value. Good? All right, now what they want me to do is take the derivative of my f of ln of x. Okay, so we're just going to do right here, we're just going to do chain rule, right? Okay, so when I do chain rule, that's going to be 2 times the ln of x, technically to the first power, and then I take the derivative of the inside, and the derivative of ln of x is 1 over x, plus, and now I'm going to take the derivative of the second part, this right here. Well, this is a constant, so remember I'm going to bring that along. It's like doing product rule. So I keep this, and I'm just going to take the derivative of this, because when I do product rule, the second times the derivative of the first, that just cancels out, right? So I just have 2 times 1 over x. All right, so I'm going to make that look a little bit prettier. So this is going to give me 2 over x times the ln of x plus 2 over x. Okay, so when I look at this, that looks pretty close to choice A. So what it really is doing in choice A is just making a common denominator. So my numerator would be 2 ln of x plus 2, and there's your answer. Okay, so for number 14, the answer is choice E. Now, this question, just be careful, it says which one must be true. Okay, so you have to know for a fact. Okay, so what I did was I drew a picture, and this is of the second derivative. So if I was doing a sign chart to go along with this second derivative, I would see that I would be above the x-axis until I get to 1, okay? And then I'm dropping below, and then I'm going back above. Now, I'm going back above at some number that's between 2 and 3. I'm not really sure exactly where it is, but I know it's between 2 and 3. Okay, so let's look at our answer choices here. Well, if you look at choice A and choice B, it says the function is increasing on or decreasing on the interval from 0 to 2. The only way you know a function can be increasing or decreasing is if you know something about its derivative. But you don't know anything about the derivative. They didn't give you anything. So we really don't know for sure whether the function's increasing or decreasing. We have no idea. So we have to eliminate those because the question says which of the following must be true. All right, let's look at choice D. It says the graph of f has a point of inflection at x equals 1. All right, well, a point of inflection would mean the second derivative changes sign, right, about x equals 1. So at first glance, I would say to myself, well, I changed sign here, so why isn't the answer choice D, right? Right. Well, now look at my picture, though, that I drew. Couldn't I have, oops, thought I had my pen going, and this is where this question I think is tricky, and I don't really love it because it's meant to kind of trick you. So here is x equals 1, right? And I just want to go through. I just drew my picture. I went from here to straight to here. But that doesn't mean that I don't take a detour here. So what I mean by that is, let me just put in my silly pen again. Okay. So here's 0, 5. Here's 3, 4. And here is 2, negative 7. I don't have to go. Couldn't I just take a little detour and go whoop like this and then go like that and then go like that? I mean, that still goes through every point they gave you in the chart, correct? So the thing is if my picture actually looked like this for the second derivative and not this, then look, there would not be a sign change in my sign chart because I'm not dropping below the x-axis here. That's tricky. So therefore, could I have a point of inflection? Maybe, or maybe not. And that's why it's not choice D. Okay, I think that's kind of nasty. All right, and then lastly, the graph of f changes concavity in the interval from 0 to 2. Yes, it does. Okay, you can see here that I'm changing concavity. Okay, and even here, if I was looking at this picture, I'm changing concavity. In other words, I'm going from above to below the x-axis, somewhere between 0 and 2. The answer is choice C. All right, so we have the integral of x dx over x squared minus 4, right? So I'm going to do u substitution here. And I am going to say that u is x squared minus 4, which means du would be 2x dx. Okay, so now that being the case, I know then that I am going to need a 2 on the inside, which means I'm going to need a 1/2, right, on the outside. So that's going to give me 1/2 the integral of du over u, which I know then is an ln. So that's equal to 1/2 the ln of u plus c. 1/2, we've got the ln of u, which is x squared minus 4. Now we've been putting them in parentheses. Technically, by definition, it's absolute value, plus c, and there's your answer, choice C.